this video, we're going to go through an introduction to recursion. Recursion is a very powerful programming technique that allows you to access some very interesting problems. The key to understanding recursion, like anything, is practicing. Before I dive into the PowerPoint presentation, I'm going to do a plug for this website here. It's called CodingBat. It's a great website to go in and practice your programming techniques. It supports both Java and Python. Has some lessons and video lessons in there as well. I use it in my class and students eat it up. They love it. So back to this. So let's start off with the main points according to Barron. So we want to avoid recursion for algorithms that involve large local arrays. Too many calls can cause a memory overflow. We want to use this process of recursion when it significantly simplifies code. So we want to avoid it for simple iterative methods. That being said, to learn about recursion, we're going to be using it in cases we would never actually use recursive technique. And recursion is especially useful for some of these processes listed below, which we might not be familiar with right now, but it never hurts to go and take a look and start reading about them. So let's first understand what is recursion. So if you look at this method, you might notice something funny about it. Whenever we look at a method, we want to identify what it takes, what its name, and what it returns. So this method takes an integer, it's called sum, and it returns an integer. Have you seen the funny thing here? It's right there. The method calls itself. So this, right away I know, because the method calls itself, it's called a recursive method. Recursion is the process of writing a method that invokes itself. But this can cause a problem, because if it keeps calling itself, it's never going to stop. So in order for a recursive method to work, we need two things. We need what's called a base case. A base case or termination condition is what causes the method to exit. And then of course we need the non-base case, and that is the recursive call. Really important that this recursive call has to step the parameter towards the base case. So for example, if I invoke sum with just n here, we're not moving the parameter towards the base case. So here are two basic examples of recursion. We often associate recursive methods as ones that return a value, but recursive methods can also be ones that don't return anything. So this method on the left here returns an int. It's called sum. It takes an int. This is the one from the previous slide. This method, there is the base case, and here's the recursive call. This method returns nothing. It's called g. Takes a string as a parameter. And then if you look, you say, well, where's the base case here? Well, the base case is actually when this method terminates, so it flows to completion. You can terminate a void method using just a simple return statement. So these ones can be a little bit harder to trace, and we'll talk about that in a little bit. There's our recursive call. So one specific type of recursion is called tail recursion. Tail recursion is a recursive algorithm where the very last thing is the recursive call. So if our method here is called f, notice the last thing in this method is the recursive call itself. So then my question for you is this recursive? Is this an example of tail recursion? Well, the answer is no, because notice, the return statement is going to execute from left to right. So the first thing that's going to happen when I hit this return statement is it's going to perform the recursive call, which is going to go back into the method. Only when that recursive call is completed will it then add 2. So the recursive call is not the last thing in the method. So this is not tail recursion. So the best way to kind of see if we can understand recursion is to go through some examples. So what value does result 5 return? So we have to kind of envision, if n is 5, we have to trace this code. And a nice way to trace recursive code is to write out something like this. Result 5, is going to call 2 times result 4. So in order to know result 5, I need to know result 4. So it's going to call the method again, result 4 is going to be 2 times result 3. Again, back into the method. Result 3 is 2 times result 2. Result 2 is 2 times result 1. Result 1 is our base case, so we return 2. So when this becomes 2, that gets passed up, and we finished the previous call. We get 4, so now I know result 2, so I'm going to, once that's terminated, I'm going to go up. Now I know result 3. Now I know result 4. Now I know result 5. So we see that the answer here is 32. So what happens with recursion is we kind of map everything out, and we have to work all the way to the end and then back up again. This technique for writing out recursive calls is really useful for understanding recursion, as well as working through some of the multiple choice problems you'd see on the AP exam. So let's look at another one. If n is greater than 0, how many times will result be called to evaluate result n, including the initial call? So again, let's write out the calls. So result 5 is 2 times result 4. Result 4 is 2 times result 3. Result 3 is 2 times result 2. Result 2 is 2 times result 1. Result 1 is our base case. And then we flow back up. So I'm just slowly having the answers disappear. Did you get n? There's all my calls. So I have to initially invoke the method, recursive call, recursive call, recursive call, recursive call, base case, so we're done. So we see that we call the method 5 times. So this one's a little trickier. I really do suggest you pause the video, give this one a try on your own. But what you might notice here is that we have 2 recursive calls. So when you get a problem like a multiple choice problem like this, setting up a branching system is really useful. So right now we're just going to kind of remove the answers one by one. Did you get that? Now you might be able to logically work this out using some common sense. But what I'm interested in is let's go through this in a very systematic approach. So I've labeled this first recursive call A, and I've labeled this second recursive call B. And this is kind of what it looks like. So this is where I start, do something 3, and essentially when I make the recursive call for A, I'm going to go left, and when I make the recursive call at B, I'm going to go right. So the first thing it's going to do is 3 is greater than 0, so it's going to recursive call A and call 2. 2 is greater than 0, so I'm going to recursive call this with 1. 1 is greater than 0, so I'm going to recursive call with 0. And then 0 is not greater than 0, so it terminates. So what happens then is I roll back to my previous case. So I'm rolling back to the call when it was 1. So it goes to the next line, and then what do? I print out 1. So I can see the first thing that's going to print out with this is 1, so I can eliminate A right away. So we're here. So then I'm going to now recursive call, but I'm going to B recursive call. So I'm going to call it with 0, return back, and then when I return back, the method terminates. So now I'm going to roll back to who called do something with 1. Well, it was do something 2. So now I return back to A and I print out 2, so it should be 1, 2. So now I can narrow it down to either C or D. So then I'm going to call the recursive call for B, so it's going to kind of come here. And now I call it again with 1, so I'm going to have to call A, 0, print out 1, 0, complete the method, back up, complete the method, roll back to my initial call, which is when I called it with 3, and then this is going to print out 3, so I should see 1, 2, so I should see, let's trace this down, I should see print out 1, print out 2, print out 1, print out 3, so I know the answer is C now, so I could stop, but we could finish this up. So we can trace all the way down, print out 1, print out 2, print out 1, and I'm finished. So this whole branching process in a diagram is really useful when you have multiple recursive calls inside of a method. It's slow, it's painful. Better off to take your time and understand how to set this up now, because it's going to be really helpful when we get into more complicated problems. And there I've really traced it for you. So A, exit, okay? Oh, seem to be able to, there we go. So here's another example of a method which has a recursive method, and I know it's recursive because I've called the method right there, inside of it. There's my base case. So, slightly different diagram, but we can still read this. So, emmet3, and again, for speed, I often just write the first letter. Emmet3 is going to call emmet2, emmet0. Now, the question is, do I go this way or do I go this way? Because the return statement is going to execute from left to right, I'm going to come down here and call emmet2. Emmet2 is going to call emmet1, emmet-1, so we're going to evaluate emmet1. Emmet1 is going to call emmet0, emmet-2, so I'm going to evaluate emmet0. Emmet0 is going to be emmet-1, emmet-3, both of which fail, so I'm going to get 2 plus 2. And then I'm going to roll back to here and call emmet-2, which is going to give me another 2. I'm going to roll back to here, which is emmet-1, another 2. I'm going to roll back to here, emmet0. Emmet0 is going to be emmet-1, which gives me 2. Roll back, 2, roll back, back up. And again, here's my tracing. Start, and that's the path that this is going to follow. So we get 2 plus 2 plus 2 plus 2 plus 2 plus 2, which gives me 12. Okay. So again, and the subtle point here is, though in this case you would get the same answer if the blue line was drawn in the opposite direction, meaning that if I went this way, it's inaccurate, because again, with this return statement, it's going to execute this version first, followed by the other one. Okay. It has no impact here. It could in other cases. What about this one? So pause it, give this one a try, and then come back. So have you tried it? This question is a perfect example where we can first remove the obvious wrong answers. For the method to print k must be greater than 1. Neither Pat nor Joe will ever be printed, since the index values are 0 and 1. Therefore, we can remove options C, D, and E. Now we could guess from here, but let's work out what the method does. So we could remove those ones. Do you see why that is? So in order to print, k needs to be greater than 1. And therefore, we're never going to get in here with 0 or 1. So we can remove those 3. So PV at 4, I've shortened print values. PV is going to call PV at 3 and PV at 2. So it's going to call both of those. And here's my tracing. So start here. Now I've drawn this out slightly differently. PV at 3, because that's going to be invoked first, right? And it's going to trace down like this. And then we identify where the print statement is executed. So we're going to start. We're going to trace all the way down. And notice the print is in between the two recursive calls. So once it has no call, it comes back up and it prints. No call, prints. No call, prints. Prints. And we're done. Last one, I promise. So now, assuming the above method has been properly declared and that the following code segment has been executed, how many calls to print values has been made, including the original call? So again, step 1, initial thinking. So the initial call is k is 1. We will write PV for print val and only include the k value as the parameter. Quick think shows that PV for k for 0 less than or equal to k, which is less than or equal to 4, will be invoked. So PV at 4 we'll call PV at 3 and PV at 2. PV at 3 we'll call PV at 2, PV at 1. PV at 2 we'll call PV at 1, PV at 0. And PV at 1 will have no call, and PV at 0 will have no call. Right? Because those are the base cases. So we could draw our diagram again. Here's our initial call. These are all the different calls. Don't double count, so it's going to call PV at 1, so that calls these two, which is, there's PV at 3, PV at 2, PV at 1, PV at 0, and then we roll back, PV at 1, 7, 8, 9. The answer is E. So your head could be spinning, being like, that's a lot. Recursion is tricky to first get your head around, and the best way to kind of appreciate and to get recursion is to start with very simple examples. So 2 suggestions for you. 1, go to CodingBat, try some of these recursion problems. There's a whole bunch of them here. You'll notice right away that the recursion problems, you could do these easily without recursion. But the key thing here is to do them with recursion. The second thing I suggest, if you're writing the AP exam, find those recursion problems, multiple choice problems, and write them out step by step. I hope this video helped, and if you have any questions, please feel free to ask. I will hopefully get this next step up soon. Have a great day.